Viewers, welcome back to BakoMaths, and to this lesson we'll be looking at how to solve systems of linear equations using Gauss-Jordan elimination procedure. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we start with the systems of linear equations. So to solve the systems of linear equations, we first have to augment matrices for the systems of linear equations. And basically you can write here as augmented matrix. So with the augmented matrix, we can write it as the coefficient of x in the first equation is 2, and then the second equation is 4, in the third equation is minus 2. The coefficient of y in the first equation is 2, in the second equation is 2, in the third equation is 2. The coefficient of z in the first equation is 2, in the second equation is 0, in the third equation is 2. And then we bring our constant terms. So 4, and we have minus 2, 4. And so the whole idea here is that we want to change this augmented matrix to reduce row-echelon form, and it is of this nature. So we have 1 0 0, we have 0 1 0, and 0 0 1, and we may get other constant terms. And so these constant terms may be the values of the variables x, y, and z. It means that you have to change these two to 1, and all other elements beneath it must be 0. It means you have to change these 2 to 1, and above and below it must be 0. And you have to change these 2 to 1, and all other elements above it must also be 0. So that's the agenda for today's video. Now we continue. So you can write our augmented matrix here as 2 4 negative 2. We have 2 2 2, we have 2 0 2, and the constant terms 4 negative 2, and we have 4. Now with this ideology, it means that we first have to change this 2 in row 1 to 1, and we can do that by writing row 1 is equal to half row 1. Since the effect is going to happen in row 1, we write it at where row 1 is. And so with this, then we can write our solution as, if you divide the whole of row 1 by half, then we are going to get 1 1 1 and 2. Since this does not happen to row 2 and row 3, we maintain the same value. So we have 4 2 0 minus 2, you have minus 2 2 2 4. Now the next agenda is for us to change the 4 in row 2 to 0, and we can do that by considering the pivot in row 1. And since the effect is going to happen in row 2, we can write row 2 is equal to, how do we get the formula? So we can get it by doing this simple illustration. So we know we are working with row 1 and row 4, and we know that in row 1 the first element is 1, and it should be row 2, so that's a mistake. So it should be row 2, and we know that in row 2 the first element there is 4. And so we ask ourselves, what must we do so that these two elements when added goes to 0, because that's our focus. So simply when we multiply the whole of row 1 by negative 4 and we add to row 2, we are going to get an answer of 0, and that becomes our formula. So our formula can be written as minus 4 row 1 plus row 2. So I can come and write it as minus 4 row 1 plus row 2. Now we continue. The next element in row 1 is 1, multiplied by negative 4, and then in row 2 we have 2. And so when added, we have negative 4 plus 2 is equal to negative 2. Now our next step is minus 4 by 1, and we know in row 2 is 0, and so minus 4 plus 0 is equal to minus 4. Now you continue with the last one and minus 2, so we are going to get minus 8 minus 2, that is minus 10, and these become the values of row 2. So our new matrix can be written as, so we have 1 1 1 2, and row 2 you have 0 -2 -4 -10, and we have -2 2 2 4. Now the next idea is for us to change this -2 to 0, and we can do that by also considering the pivot in row 1. And to get the formula easy, since the effect is also going to happen in row 3, let's write row 3 here. Now how do we get the formula? We can do it by also doing, or we can get it by doing this simple illustration. So we are considering row 1 and row 3. So in row 1 the first element here is 1, and in row 3 the next element is -2. So we ask ourselves, what must we do so that these two elements when added goes to 0? So simply when we multiply the whole of row 1 by 2, then we are going to get 2 minus 2, that is equal to 0. So it means that our formula is 2 row 1 plus row 3. So 2 times row 1 plus row 3 becomes our formula. And so you continue for the rest of the elements, and in row 1 we have 1, and row 3 we have 2. And so we are going to get 2 plus 2, that is equal to 4. And it continues. In row 1 we have 1, and in row 3 we have 2. So we are going to get 2 plus 2, that is also equal to 4. And in row 1 the next element is 2, and in row 3 we have 4. And so at the end we are getting 4 plus 4, that is equal to 8. And so this becomes the new values for row 3. And so you can write our new matrix as, so we have something like, since the effect did not happen in row 1 and row 2, maintain the same value. So 1 1 1, and we have here 2 0 -2 -4 -10, and in row 3 now we have 0 4 4 8. Now having gotten this, the next agenda is for us to make this -2 to 1, and we can do that by also dividing the whole of row 2 by -half, and with that we can get the value of row 2 now to be 1 as we want it. So since the effect is going to happen in row 2, you can write here as row 2 is equal to -half row 2. And when we divide the whole of row 2 by -half, then we are going to get an answer of, so we maintain the same values for row 1, remember, 1 1 1, and we have here as 2. And for row 2 now, half times 0 is 0, and half, -half times -2 is 1, and with this one I'm going to get 2, and we come here we have 5. And then maintain the same values for row 3, so that becomes 0 4 4 8. So having done that, our next focus is to make sure that the 4 here goes to 0. And so we can do that by considering the pivot in row 2. And so simply we can also do that illustration, and that will help us in doing it. So remember, we are changing this 4 to 0, so that is going to happen in row 3. And how do we get the formula? So we are considering row 2 and row 3. So the first element in row 2 is 0, and in row 3 is 0. So when we add them, we are going to get 0. But that is not our focus. Our focus is to change this 4 to 0 by considering this 1. So we have 1 and 4. And so what must we do so that these two elements when added goes to 0? So when I multiply this by -4 and I add to this 4, I'm going to get -4 plus 4 is equal to 0. And so my formula now becomes -4 row 2 plus row 3. And so I can come and write it as -4 row 2 plus row 3. And we continue for the rest of the other values. So -4 multiplied by 2, and in row 3 we have 4. And so we are getting -8 plus 4, and that gives us an answer of -4. And so we continue, and we have -4 multiplied by the next element, that is 5, and we have 8 as row 3, and so at the end we're getting minus 20 plus 8, and that will give us minus 12. And so our new set of row 3 values are 0, 0, 4, negative 4, negative 12. And so our new matrix can be written as 1, 1, 1, and we have 2, so we have 0, 1, 2, 5, and for row 3 now we have 0, 0, 0, negative 4, negative 12. Now the next idea here is that we have to change the 1 we see above the 1 in row 2. Yes, so the ideology here is that we want to change this one also to 0 by considering the pivot. So since the effect is going to happen in row 1, you can write row 1 here is equal to, now how do we get it? Let's do this simple illustration. So we are considering row 2 and row 1. Now you know the first element in row 2 is 0 and in row 1 is 1. And so when we add this, we are going to get 0 plus 1, that is equal to 1. But the formula has to affect this. And so our main focus is to change this 1 in row 1 to 0. So that will be our focus now. So it means that we are in row 2, sorry, we have 1, and in row 1 we have 1. So we ask ourselves, what must we do so that these two elements, when added, goes to 0? So we have minus 1 plus 1. So minus 1 plus 1 is equal to 0. Our formula now becomes minus row 2 plus row 1. So you can write it as minus row 2 plus row 1. Now it means that the minus have to affect the first element in row 2. And so minus 0 plus 1 gives us the same 1. So we don't get bothered about that one. So you continue for the rest of the elements, and we have, and you know, in row 1 we have 1 here. So since we are subtracting, we bring it, and at the end we have minus 2 plus 1. That gives an answer of minus 1. So in row 2 we have 5, and since we are subtracting, we bring it, and in row 1 we have 2. And so 8 addition gives minus 5 plus 2, and that gives us minus 3. And so our new matrix can now be written as, so in row 1 we have 1, 0, negative 1, we have negative 3, and we maintain the same values for row 2 and 3, and we have 0, 1, 2, 5, and we have 0, 0, negative 4, negative 12. Now with this, our next agenda is for us to change this minus 4 to 1, and since that is going to happen in row 3, you can write row 3 is equal to, so now we have minus 1 out of 4 row 3, and that will give us this minus 4 to be 1. And so we can write our new matrix as, so we maintain the same values for row 1 and row 2, and that is 0, 1, 0, minus 1, minus 3, and we have 0, 1, 2, 5, and we have 0, 0, and when we divide minus 4 by minus 1 out of 4, then we are going to get 1, and at this point we are getting 3. Having done that, our next procedure is to change these two to 0 by considering this pivot. So since that effect is going to happen in row 2, let's write it as row 2. How do we get the formula? We can do it by doing this simple illustration, and we are considering row 3 and row 2. But then we know that our focus is on this 1 and the 2, so we can write it as 1 and 2. We are writing at the bottom because we have other element there, so you have to get the formula and then know how the formula is going to affect these other elements. And so we ask ourselves, what must we do so that these two elements, when added, goes to 0? And so we multiply row 3 by negative 2, and then we add to row 2, then we are going to get 0. So that is minus 2 plus 2 is equal to 0. And so our formula now becomes minus 2 row 3 plus row 2. So you can write it as minus 2 row 3 plus row 2. And so the first element in row 3 is 0. So you write 0. Remember, we are subtracting and then also multiplying. So we bring it, and in row 2 is 0. And so at the end we are getting 0 plus 0, and that is 0. Now the next element in row 3 is 0. So minus 2 multiplied by 0, and in row 2 is 1. And so this is going to give us 0, and we have our 1. So it should be 1. So we clean this side, and we come and write 1. And so we continue, and we know that in row 3 the next element is 1, but we have written that already here. And so you continue with the next element, that is 3. So minus 2 multiplies by 3, and in row 2 we have 5. That gives us minus 6 plus 5, and so we have here to be minus 1. And so you can write our new matrix as. So we maintain the same values for row 1, and we know in row 1 we have 1, 0, negative 1, and we have negative 3. And then that of row 2, our new values for row 2 is 0, 1, 0, negative 1. So you write it as 0, 1, 0, negative 1. And we maintain the same values for row 3, and row 3 we are having 0, 0, 1, 3. So 0, 0, 1, 3. Now the next idea is that we want to change this minus 1 in row 1 to 0 by considering the one we see in row 3. And so since the effect is going to happen in row 1, we can write it as row 1. And so how do we get the formula? We can get the formula by following the normal routine. And then with that illustration, we can simply write here as row 3 is what we are considering, and row 1. And we know we are focusing on 1 in row 3, and then the minus 1 in row 1. And so we ask ourselves, what must we do so that this element goes to 0? So simply 1 minus 1 is equal to 0. And so our formula now becomes row 3 plus row 1. And so this 1 and negative 1 happens to be the third element in the matrix. And so let's see how the formula is applicable to the rest of the elements. And so in row 3, the first element is 0, and row 1 is 1. And when we add 0 plus 1 is equal to 1. Nothing changes. And so in row 3, the next element is 0, and row 1, the next element is 0. And so when we add these two, we are going to get 0. Before the 1 and negative 1, we have done that. And so we move on with the next one, that is 3 in row 3, and minus 3 in row 1. And that one too, when we add, we are going to get 3 minus 3, which is equal to 0. And so this becomes the new element for row 1, and we can write our new matrix of this form. So we have in row 1 now we have 1, 0, 0, and then the last one 0. And then we know we maintain the same values for row 2 and row 3, and that becomes 0, 1, 0, and we have minus 1, and we have 0, 0, 1, 3. So at this point, we have been able to change the augmented matrix to the reduced row echelon form we talked about earlier. So with this ideology, that means that we are going to do back substitution. So we can write here as, so by back substitution. So remember that this column was column for x, and this was column for y, and this was column for z. And remember, these are constants. And so with that, what must we do? We are just going to multiply. So 1 times x is basically x, and 0 times y is 0, 0 times z is 0. And so the x should be equal to the constant 0. So it means that x is equal to 0. And then we move on. 0 times x is 0, 0, 1 times y is y. So we have y to be equal to, now 0 times z is 0, and y is equal to the constant negative 1. And when we come here, 0 times x is 0, 0 times y is 0, 1 times z is z, and then the z is equal to the constant 3. And so this is how we can find the values of x, y, and z using the Gauss-Jordan elimination procedure. And so this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths, thinking beyond infinity.